Hello everyone, welcome to Driven Math and Physics. So we have a problem here of velocity time graphs. It says a car initially at rest moves with uniform acceleration for 10 seconds until it attains a velocity of 30 meters per second. So we need to sketch a graph, that is part A, draw a VT graph of the motion. So to begin with, we need to first of all do this. Let's draw a pair of axes, okay? So a pair of axes that are going to look like that. Okay, and then we're going to label this one as time in seconds, and this one will be velocity in meters per second. Okay, so they're saying this car initially it's at rest. Okay, so it starts from 0 and moves with uniform acceleration for how long? 10 seconds until it attains a velocity of 30 seconds. So what we're going to do is we're going to find a mark, and that mark will label 30 seconds. All right, and it has a uniform acceleration for 10 seconds. Okay, so what we're going to do is we're going to put here 10, 20. Okay, this will be 30, this will be 40, this will be 50, this will be 60, this will be 70, and this will be 80. Okay, so he accelerates uniformly, the car accelerates uniformly for 10 seconds until it attains a velocity of 30. So that point is literally this point right here. Okay, so we're going to draw a line of uniform acceleration from the rest position to that point there of 30 meters per second. It says it then proceeds at this point, it then proceeds at this velocity for 20 seconds. So it stays at 30 meters per second for 20 seconds. So 20 seconds from 10 seconds is actually 30. That means it stays at 30 meters per second for 20 seconds. That means by the time it reaches 20 seconds, it will be at 30. Time would have passed as 30 seconds, okay, in total. Okay, so from there, they're saying that finally it comes to rest after retarding uniformly for a further 5 seconds. So if it's a further 5 seconds, it means it's this point in between 30 and 40, or 35 right here. Okay, and it reaches that point after 5 seconds. So we'll do that up to that point. Okay, so this is the motion of the car from the point of rest to a point that is 35 seconds later when it comes to a stop. Okay, so part A has been dealt with. Part B now is saying from the graph calculate deceleration in the final 5 seconds. So in the final 5 seconds, we're talking about this area right here. So they want us to calculate the deceleration. You remember, acceleration, so deceleration is simply negative acceleration. So acceleration is equal to change in velocity over time. So here, the final velocity is 0 for the deceleration, minus the initial velocity. It started from 30 decelerating meters per second divided by the period of time for the deceleration is 5 seconds. So when you calculate it's negative 30 meters per second over 5 seconds. This gives you negative 6 meters per second squared. So this was the deceleration in that final 5 seconds. Okay, so they're saying this one is dealt with. So they're saying we should find the total distance moved by the car. Then for this one, we're going to do 2 methods. The first one is going to take advantage of the area under the graph. But next up, we'll look at using equations of linear motion to actually calculate the total distance under the graph. So we're going to see that in the next video. But for now, we're going to use the area under the graph. Now, so to find total distance, we'll need to observe what shape we have right here. Okay, so if you look at the shape of our motion, it's simply this figure right here. Then this figure is literally a trapezium. Okay, this is a trapezium. So if we're going to find the total distance, we'll simply find the area of trapezium, which is the area under the graph. Okay, so to find that will be half sum of parallel sides multiplied by height. Okay, so half the sum of parallel sides. The parallel sides are this one right here and this side. These ones are parallel. So when you look at the magnitudes, the first one is from 10 to 30. That is 20 seconds plus. So that is the sum. So it's plus. Okay. The other parallel side is from 0 to 35. So it's 35 seconds. Multiplied by the height. The height is this one, which is 30. Okay. So we'll put times 30 meters per second. Then this half goes into 30. We have 15 meters per second from there. So from there we can say 20 plus 35 gives us 55. That becomes 55 seconds multiplied by 15 meters per second. Okay, when you do the multiplication like that, it should give us 825 meters as our answer. So this is how you find the total distance traveled by this car, by calculating the area under the velocity time graph. Yeah, so this is what we're going to do in this one. But next up, we're going to look at how to calculate the same distance, but by now using equations of accelerated motion. Thank you so much for watching.